So we will move to next presentation. Next presentation will be made by Frank.
Yeah.
Okay.
Okay.
Okay. Start.
So, konnichiwa. Good afternoon. I'm going to present, well, no, I'm not going to present, sorry. I need different glasses. That was a mistake. I'm going to talk about a project by the LaTeX developers, a multi-year project, and the title of my talk is Enhancing LaTeX to Automatically Produce Tagged PDF and Accessible PDF. The term tagged here, by this we mean that we identify the structures of the document and carry it to the output format, and the main format LaTeX normally produces is PDF. That's why the title there, and this is the one where we have most urgency right now to enhance the situation. Automatically, as far as my talk is concerned, means we do not have manual post-processing. That's the goal. Everything should come out finished. Okay, so my talk has 5 parts, if I manage to get through them. First, I talk a little bit about how LaTeX is placed in this scene. Then I talk about our multi-year project. What are the goals? What is the current status, the achievements that we made so far? What are the ongoing and future project tasks? And finally, specific aspects of our project work. And then I hand over to my colleague in Germany, Ulrike, who's doing the fun part and actually showing you what works. And I'm much excited to see what she's going to tell us, because a lot happened in the last couple of weeks and I'm not aware of what she's going to talk about, so we will see. Concerning LaTeX. LaTeX is old and at the same time quite successful. We are, as a project team, we are having our 3rd decade anniversary this year. LaTeX itself is nearly 40 years old when Leslie Lamport introduced it first to the world. So it is highly successful in the STEM world. I'm not going to talk about this. I guess Charles tomorrow is saying a little bit about this. So let's skip over this. What's the initial focus that LaTeX had when it was designed and throughout those 40 years? Well, it is structured input. That's a very important part. The authors can focus on their work and not initially shouldn't. And when they do, then they get into the hell that Volker was talking about. But the idea is to produce your document by thinking about the structure of it. At the same time, you can fiddle around and you can get any kind of output from it, so it's very, very flexible at this. And this is also the problem when people have struggling with it. High quality output. We all know about complex mathematics. It's unraveled there. But there are many other parts in which LaTeX is one of the forerunners in the field if it comes to high quality. Again, I'm not talking about this. But beside the good points, there's also a but, of course. And one of the buts is it was originally designed just to print on paper. Now, why is this a but? Well, there's something lost in translation. And it's not the film which is playing in this city. LaTeX means structured input, but due to a number of reasons, it discards this information as soon as possible in the process. And by the end, you come to the output, it's just dots, white and black stuff, but no structure. And the reason for this is it was designed when computers were small, slow, and actually not meant to do any of this. And so the design was taking care of getting rid of everything that is no longer needed. And for print, it is not needed by the end of the day. But nowadays, we are not only printing, actually printing is a second level quality. We are using LaTeX output or PDF or whatever documents, not for printing, but for viewing, for accessing, for diving into, for taking data out of it. And for this, you have to have the structure of the document, or you have to guess it, which is usually a bad thing to do. Now, fortunately, computers are much, much more powerful these days than they were when LaTeX was designed. So there is a chance to do this because LaTeX has the information in the beginning to carry it through to the end. And for that reason, we have been starting a multi-year project called the LaTeX tagged PDF project. Now, why multi-year? Simply because we are operating on a live body. And we have to do this very carefully so that the patient is not dying along the way. We have millions of users out in the world. They rely on LaTeX being reliable from start to finish, from 10 years ago, from 20 years ago. The stuff is still working if you have your documents. And this needs to remain. And if somebody is writing his thesis and we change LaTeX under him and it suddenly doesn't work when he's going to defend it, that's not a good thing to have. So it has to be done very carefully, and it takes time to do this, and this is why it's a multi-year project as part of it. Now, I said PDF. It is not just about PDF, but PDF is the main output format of LaTeX, and there are good reasons for it in many cases to be like this. So PDF is at the forefront of this project initially. So, goals. I mention here 4 major goals that are part of this project. First of all, I already said it, enhance LaTeX so that it can automatically produce tagged PDF. No manual post-processing. If you change your source document, you don't have to redo all your accessibility work in the post-processing because it's part of what LaTeX is going to produce. That's extremely important. Otherwise, you will not get accessible documents unless you force the author to do it, because it's extra work for many people. They have no immediate need for it, and so they're not going to do it unless forced. And if it can become automatic, that's the step to actually take. The second point is we have millions of documents out there. They're sitting 2 million of it or something over there in archive.org, for example. But 40 years of LaTeX documents means there is a huge amount of knowledge and information in those documents, and they are still around because they still work. And we want to make those accessible too as far as possible. So the goal is just to have a single line of configuration on top of your existing LaTeX document, rerun the thing, and you get an accessible document. That's the goal of the project. Third goal is to use PDF 2.0 standard, and with it, the new PDF UA2 accessibility standard, and produce documents that comply to this standard. The new one, PDF UA2, just came out in January, so it's pretty off. And if we are able to produce those documents, we are actually on the forefront with LaTeX, we are then one of the first, if not the only one, who can automatically produce documents according to those standards. Finally, the fourth one is we have the initial focus on PDF, but what we are doing is with the design to also improve accessibility of other output formats produced from LaTeX. So in particular, HTML or some XML for post-processing, etc., and so forth. So this is part of the bigger story. And yes, okay, so what are the current achievements? What's the status? First of all, the basics, the need to redesign part of the internals of LaTeX, to extend and produce new functionality for enabling these kind of automations. This is done. We also have a library to manage PDF objects within LaTeX. We have a library to manage tagging information within LaTeX. And this means altogether to use LaTeX and produce a tagged PDF and an accessible PDF manually is possible. It's actually possible for quite some time, but of course nobody wants to do that. But you can write a LaTeX source and you get out a tagged PDF, which is accessible. The interesting question is, how far are we with automatic tagging? Now, I would say quite a good news is if we restrict ourselves just to the book that Leslie Lamport wrote, and we write documents using that book, then LaTeX is fully accessible. Producing PDF output, which is fully accessible and obeying to UA standards, say. On top of this, we have a number of the LaTeX extensions, packages already made tagging aware. The most important is complex mathematics with the AMS math, which covers most of what people use with mathematics. HyperRef for external and internal cross-references, bibliography packages, table packages, and several others, but of course, some of them are still a lot of work in progress. Nonetheless, as a summary, we are today able to produce documents using PDF 2.0, producing in 2.0 or in 1.7 if necessary. And we are able to produce documents that are conforming to the new standard, Universal Accessibility Standard. As a side note, this conference talk, the paper that we put in, was actually accessibility when we gave it to the conference. It is no longer in the big PDF that was made and put everything together, but all we had to do, in some sense, we had to fix a bit of the LaTeX class, but the bugs were not actually in because of the tagging. It just showed up as because of the tagging. But all we had to do was to add this a little bit strange line because we are still in the testing phase. And it came out accessible. And I'm pretty sure that most, if not all, of the LaTeX contributions to this conference with this line would become accessible as well. Would be interesting to see. The Word documents wouldn't, but would be interesting. Anyway, two important notes here. First of all, we label the current work still as experimental. The main reason is, we don't have yet all configuration possibilities that we want to have by the end of the day. Second, we experiment with the users that are actually using it right now. This gives feedback. The feedback is possibly something that is going to make ourselves change certain things. So it's not in its final form. That's why it's still considered experimental. But given the current situation, you can actually produce documents with it. I wouldn't use it on a sort of production phase in a company, because we are still going to change underneath. Second notice is we have achieved quite a lot, but as far as mathematics and tables is concerned, we are just at the beginning. And there are open questions around both areas, and there we need a lot of input from the community. And I think with Volker and those folks, there will be some fruitful discussion possible on some areas, and with others as well. Okay, so ongoing and future tasks. There are 3 tasks here on the display, which are basically, I would say, understood and straightforward, but a lot of work. First of all, we have to do some finalization of user interfaces still for tagging documents. We have, of course, LaTeX is an open system. We have, I don't know, 5,000 packages on the LaTeX distribution, and some of them are really very specific and not so important to be in a first phase available, but the majority of those packages actually have to made tagging aware to become successful. So this is huge, and it needs help beyond what the project itself can do. It needs the developers of those packages to join into the effort as well. And finally, there are many specialized document classes, like the one for this conference. The one for this conference is based on some standard article style, but it is based on some standard article files and was maybe done 15 years ago or 10 years ago, and then it was modified. Those special classes, of course, need to be made tagging aware as well, especially in something like the title page of those things. There are so many specialties. This has to be done by the people maintaining the class. This cannot be done from the outside. So we have to provide interfaces for them, which makes it really easy for the developer of such a class to make it accessible. The focus for us in as the LaTeX developers in 24 is twofold. We will go very strongly after mass tagging beyond what we currently can do, and we will go into table. Both require research, but of different nature. And this brings me to the specific aspects of this this project work. First of all, concerning formulas in STEM documents. If you look at the tagging those in PDF, then we have basically 5 possibilities. One is we use alternative natural language, which is what was proposed for 1.7. So for every formula you have to write in English or in whatever language what it means, like you describe tables, graphics. Oops, good. The second possibility is take the LaTeX source, put it into alternative text in some form or shape, which is in some sense the solution. Volker was explaining near to that solution concerning Braille. The problem here is AT tools do not play very well, and in all cases, and they play in different ways. There is no consistency. So what works with, I don't know, one tool may not work as with another tool. There's a problem of consistencies to actually render the stuff or read it out to you. If for example, the punctuation characters are simply dropped, then most of the information is becoming useless. If you have a math formula read to you and the parentheses are gone, then what do you do? Then there are three other possibilities. MathML directly embedded in the PDF document, MathML embedded as an associated file, and you can also embed LaTeX source as an associated file. For the last three solutions, you need actually PDF 2.0, and the problem with PDF 2.0 is, so far, there are not really a lot of tools that can handle it. The reason is, again, chicken and egg. Nobody produced documents with 2.0, therefore nobody felt compelled to produce applications that use it, and vice versa. So they both stopped each other. Now we are, in some sense, the changing factor. We are suddenly able to produce complex documents in 2.0, and a lot of people get surprised that their tools have difficulties and looking into getting this fixed, because now the mathematics and everything is coming. So the question is, what kind of support for formulas is actually the best, and what kind of combinations are maybe necessary? And then we have to get the problem of standardization in the tools solved as best as possible, and in the meantime figure out how to work with this. Because as I said, if one tool is able to make use of an associated file or of MathML and the next tool is not, then you have problems actually making use of such a PDF in the world out there. So there is some need for working with the application developers and the application companies. But the good news is, it seems to be that through the fact that we can actually produce a lot of test documents now, for the first time in some sense, that is actually resulting in seeing some movement in that space. So I'm really hopeful. The second part is tables. For simple tables, everything is done, so we can tag them. For complex tables, we have the problem that LaTeX, unfortunately, has one deficiency in structured input. Tables are structured by their visual appearance, not by their logic. So if you want to understand what are table headers, you actually have to have heuristics, because it's not expressed in the source. It's only expressed by making something bold or putting a line or something there, but that's not the same as saying this cell is a header cell for this row and for this column, and this is a header cell for this row, or these two cells belong together, etc., etc. There's no logic being implemented. And so what we need to do as open task is we have to develop good heuristics to detect what is inside a table, maybe steal some from some tools that already have them. But at the same time, we also have to develop an extended syntax to override the heuristics if the heuristic is simply wrong, because the table is technically looking like this, but in fact is representing something else. And furthermore, we want to develop a new table model based on logic. But of course, the new table model would only work for new documents. And as I said, we have millions of existing documents that we want to make accessible as best as possible. So the heuristics is a research area. And finally, two more topics from the specific aspects, just briefly. As part of the project, we are developing what we are currently calling a LaTeX namespace for tagging, could be called a STEM namespace for tagging, or complex document tagging. The point here is LaTeX has very rich semantics as far as the structure is concerned. And if you look at something like PDF 2.0, or if you look at HTML, that has very little semantics, really. So if you translate from LaTeX into such structures, you lose information. So what we are currently working on is a standard set of structure tags that represent not the whole universe of LaTeX, because LaTeX is open-ended, but a good representation of the majority of documents that are actually being produced. And this set of tags is then proposed to become a standard set of document structure tags. And we hope this way, if we can get the buy-in, that such a recognized tag set is then actually being, over time, used by applications, PDF applications, and therefore enriching their speech production or whatever they do. In case the application doesn't understand the tag set, it is automatically rolled into the less granular PDF 2.0 or even less granular PDF 1.7 tag set. So we are losing information this way, but at least we get consistent structure. And if the application is using the tag set we propose, then we get a step further. This has, of course, this is what I just said. This has, of course, also meaning beyond PDF, because such a standard tag set can enrich the process of converting to other formats, because then you have the additional semantic information through the tag set, which is otherwise not there or has to be heuristically gathered again. All true. Yes. The comment was it also makes a better archive format. Final word, very briefly. We currently working basically with Latin-based languages, or languages which are very similar to Latin, quote-based, like Greek or so, which we understand more or less because we come from that culture. We do not understand a lot of other languages, like Arabic, like Japanese, Chinese, which may have different kind of requirements as far as accessibility and everything is concerned. So we need a lot of help to see and understand if we are missing something, how well it applies to different scripts, different languages. So testing, reporting issues, working with the stuff we are currently producing, telling us what kind of features are missing possibly to make things truly accessible, is one thing where we are looking for further help. Now with this, I want to finish off. Thank you for listening, and I'd give over to my colleague. I hope, if we don't get into any trouble with remote presentations, I give over to Ulrike. Thank you. Question at the end. It's a combined talk. Yeah.
You can receive the question at that time, and next you can switch to.
Well, I can take questions now if that's preferred, but I mean, Ulrike is presenting what I just talked about.
Okay.
So, whatever you want. Questions now? Okay, so Ulrike, are you there?
Yes, do you hear me?
Yes, I hear you well. I don't see you, but that doesn't mean anything.
My video start.
It also has to be put on the screen. It might already have started.
I'm just trying to share my screen. I now want to show more concretely what Frank has spoken about. I would like to start with the requirements if you want to try this new code. This is new code, as Frank said. So you really need a current, up-to-date test system if you want to start with tagging PDFs. It is in development, and you even need sometimes the newest latest dev, for example, for some stuff that I will show it in the example, the newest latest dev that we released yesterday. And as I said, some things are still missing, and we still change things based on feedback. The demo use as engines Lua LaTeX, as Lua LaTeX has really the most options for tagging. Things like real space cars and handling mass is typically much better with Lua LaTeX. You can also try with other engines like PDF Tech or perhaps UpLaTeX, but they have less options and are not necessarily tested as well as Lua LaTeX. If you want to start with tagging, you need a few tools. You need something to actually see the text. For example, a PDF viewer like Acrobat Pro or a Foxit editor, PDF Exchange can also show text tags. You can also view tag PDF on ngpdf.com, which translates the PDF into HTML and so shows you something about the structure of a PDF. The PDF viewer, as Frank says, typically support only PDF 1.7. Many PDF 2.0 features are simply not shown. So if you want to see them, you have to go to ngPDF or look into the PDF directly. To handle the MassML attachments, which I will demonstrate, you need a development version of Foxit and a development version of NVDA and the Mascat plugin. More details, I guess, will be tomorrow in the talk of Neil Safay and Roman Toda. We will speak about this software, which really improves the reading of mass and in a tech PDF. Now I want to show a general example document. Can you see the document? I hope. If not, someone will have to complain. I'm showing here a standard LaTeX document. It starts with a command that Frank mentioned in his talk, the document metadata command, which is a trigger command which tells the document that this document should be tagged. There's here a number of a test phase key, which loads a number of test phase modules in which we implement the new tagging code. Phase 3 combines support for various elements like lists, footnotes, sectioning, margin part that is quite new, bibliographies, floats, and graphics. There's a special module for math, as math is quite experimental and sometimes break documents, so you have to load it explicitly. There's a module for tables, which supports tabular, tabular X, and long table. There's now also a new module for titles, which supports the standard make title command from the standard classes. This, in the document metadata command, you can also set some PDF related features like the PDF version and the PDF standard here. This is all that is really needed for tagging. The rest of the document is a quite standard LaTeX document. I changed a bit the page sizes so that it shows better in the presentation. I load Unicode Math. This is a Lua LaTeX document, and Unicode Math is good for accessibility. I load hyperref and graphics, change a bit the font, but beside this, there's not much in it with the exception of the setup command. This is still needed to tell that the tables have a header in the first row. As we said, as Frank said, we currently cannot really detect where a header of a table is, so we have to tell the tagging code. And beside this, we have now a make title, table of contents, sectioning. We have some verbatim in the file. We have footnote, description list, more sectioning commands, references. Here I have a graphic, and the graphic again shows something that it must be changed if you do tagging, because here we have to add an alternative text. This is required that you tell the users what the graphic is about. So we have to add an alt text. This is something that also we'll have to do additionally when tagging. But some math and again an enumerate and a table. So this is all a normal LaTeX document. Okay, now look how this document looks like if tagged. The page size is a bit smaller so that it fits better on the screen, but tested it is a simple document. And on the left in Acrobat, for example, you can then check the text. You can see that it had text everywhere. Here's a section with a table of contents, a contents line, the second contents line, go a bit. Here's, can really navigate through the text to the various parts of the structure element. In this case here, this shows a standard PDF text, but one can change this and remove. And now we see the LaTeX namespace, that subsection that Frank mentioned, that where development, that we call this a table. There's a table below. Here's a table with header sets. This shows us how you can, if you have a simple document, you can already tag it, it works. And you only have to avoid to use too complicated packages or classes which are not compatible with this. Now, the most important part is mass tagging, which is really open in PDF. We have been experimenting quite a lot with it, and within The newest version that we are now using, and which shows really promising results, is to attach MathML as a file to the structure element, MathML, and to let it read then from a screen reader. This works only currently with the development version of Foxit and with the development version of NVDA. But here I show a bit how. I won't show this in real life because I can't handle the sound system. Would be too confusing. But I copied and pasted the output from the NVDA speech viewer, the text output. And you can see here that the math is really read quite a sensible way. So the standard quadratic expression here, the solutions to rx squared plus bx plus c is equal to 0. And it knows about numerator and it knows about denominator. This is quite useful math. Here we see that it also knows about the absolute value if the MathML tells him that that is meant to be an absolute value. And here we have an equation system, and that is it really tells you that line 1 has something and line 2 has something. And depending on how good the MathML is that describes the equation, you can also improve the reading experience. How is this done? I want also to show a more complex example. We have converted an article that we found on arXiv. I really want to show how this looks in ngPDF. I hope that I need to make it larger. An ngPDF shows you the PDF and an HTML side by side. And we can go to the look actually. Now I lost. Sorry, I lost the ngPDF. I cannot see because the bar of the Zoom is all showing smaller. I will stop this. So you can, on ngPDF, you can look that there's a more complex example, and how do you create such a PDF with MathML attachments? The first thing that you have to do is to create a dummy by adding a setup command to your document, and this will then, here we have the setup document, and this will then write a dummy HTML file with dummy sections for every math in your document. So here we have equation for the quadratic equation. It contains a hash number which describes the equation which is used to identify the mass, and it has an empty mass section in which you can copy or paste or include MathML. So here's a second equation, again a bit longer, and here I have a third. You then have to fill in this dummy MathML. Here I filled in, here were longer MassML in the equation. And here I have the second MassML. Here's a MassML which has an intent for the absolute value, and so on. Once you have this MassML, you rename it. When fill the match, you rename it, and then you recompile your LaTeX document, and LaTeX will simply use all these MassML and put them into the PDF. This is automatic. So how do you get the MassML? That is a really interesting part. We used various methods and experiment with them. One was that did go to ArcSF, take their generated HTML versions of the articles and extracted the XML that they produce with LaTeX XML. Another option that we tried is to use TeX4HT, which produce XML2, and which still, again, with some script, can extract the XML and copy them back in our dummy file. You can also do it manually by using, for example, mathJax, as demonstrated previously. It is able to convert a LaTeX equation into XML, and you can then copy and paste it back into your document. If you are good in XML, you can naturally write it also manually. In the current system, you can improve the XML if you want. You can check, as we decided on a simple HTML file. We can simply load this HTML file in a browser and check if the mass looks good. And if there are problems, we can also load it into some validators, and which can tell us if there are errors in the XML. We are also thinking that if once you have such good XML for your equations, it could be feedback also to the HTML processors. They could read in this file too and use them for their own production and so enhance the XML they produce automatically. What are problems currently? The method to get the XML is only semi-automatic. It requires some work from authors and also some knowledge about XML. And this still will take some time until we find good methods to ease this. We found, for example, this system like LaTeX ML and TeX4HT have different ideas than TeX has about equations. They split sometimes equation systems in more than one XML, while TeX sees only one equation. There are also problems with non-mass parts in a document. For example, if an author uses superscript simply because you want a superscript instead of TeX superscript. The XML is not always created by, or it is simply not sufficient because it doesn't contain intents and other things that make it a really good experience. So that we need also tools to automatically improve and validate the XML. Nevertheless, it's really, really much better than what we got until now, where nearly nothing was really read from a mass. Now, I thank you for your attention, and now we can go to the questions. So where is...
So, questions?
I have about 1.5 million questions. I will start with the two first. I have maybe I did not understand, but you said at the beginning that if I have an old LaTeX document, I want to make it, to tag it, then I need to add a line and then to recompile with a more recent version. But why do I need to add a line? Why does this automatic?
Who should answer?
I don't know. I can certainly answer that. I was waiting for getting my mic actually doing something that I can hear. Why do you need to add a line? Well, technically, first of all, you need to specify certain information, what you want to tag, how you want to tag, because there's a difference if you target for PDF UA or if you want to tag for PDF A4 or non-standard. This kind of information has to be given somewhere.
But you can have some default values.
You can have some default value, that's true. But the second point is also there are good reasons why you do not want to tag every document. So we will have this configuration option both to show to enable internally completely different processes. So documents without tagging and old documents that should not be processed in a different manner, so to speak, and those that actually use new code and possibly produce different renderings. So if it comes down to produce 100% the same printout, then we will never ever be able to achieve this. So we use this also to get rid of certain kind of layout issues that LaTeX carries with it for ages. And say for new documents, we are free to produce differences. So this is like the change from LaTeX 209 to 2E, where we said we go from document style to document class. Now we make another big leap and we go and add on top document metadata that says new document.
And then you say, at what version, because you say you have to have a new version up to date. I have up to date Debian here testing. So what is the number of versions? Is it possible to have a clear?
When you say up to date Debian,
yeah.
Debian is an operating system thing. The question is, what is your LaTeX distribution or tech distribution? Typically on Linux, they are years back in reality. Mm-hmm. So up to date means today it would mean LaTeX from November 23, okay, plus the development release, which was released yesterday. So, you don't need that for tagging. I mean, as I said, I produced the article for this conference, and I gave, when was this? In November. So you could do tagging there, but to get the latest version of some additional features that we are currently sort of providing for testing and for usage, you have to have the latest version. It goes rapidly on. So yeah, I would say for reasonable tagging, you need the version from November 23.
Thanks a lot, and a lot of people like me are waiting for this since 20 years. So.
Yeah, well,
that's great. Thanks a lot.
Thank you very much for the very interesting presentation. my question, I have two questions. Your library, is it included in the standard newest LaTeX compiler, or do we need some additional style files or something like that?
No, it's just standard LaTeX distribution. So if you have Tech Live, then you get LaTeX and you get the LaTeX development version. So if you are on a command line, I mean, if you're working with an environment which hides all this, then it's a little bit different. But each of those can do it as well. If you're on a command line, you normally say something like PDF LaTeX blank file name, or in Japanese you would do up LaTeX or something blank file name. And then there is a version which has the -dev, DEV, for development, which we release at irregular intervals between the big official main releases. So people like developers can already test what comes up in the next main release by using our development version. So for example, the next main release will be in June. Right now we do it twice a year. And the development versions come out whenever we feel like we have something that people should test or use. And a lot of the tagging functionality, of course, is in the development version first, but it is also in the main version. So in the November version of LaTeX, you have already tagging up to version test phase 3, but there is no, I think the table one is not yet in, and the certain functionality is not yet in, it's only in the development version. Yeah, correct.
Table is in, the title not.
Okay, so something is in and something is not because we adding stuff. Let's say it this way. As I said, I'm currently a little bit behind everything for various personal reasons, but you have a standard LaTeX, that's all you need. Like MikTeX or Tech Live or something, and then you have to enable, or you have to make sure that you get the latest versions of the files.
I think it's wonderful. That's what I wanted for a long time. So it's wonderful. The second question, is it possible to make PDF speak?
Yes, it is possible.
Is it possible?
I mean, Ulrike couldn't show that throughout the presentation through Zoom, but yes. I mean, if you have speech software with PDF, for example, Acrobat can read it to you. VoiceOver on the Mac can read it. I find VoiceOver hard to manage, but I know that people who are blind work with it quite well. I don't know. For me, it's very difficult to manage because it speaks so much to me. But
can I ask a question?
Of course, you can ask a question.
Is it possible to make PDF speak?
Yes.
I think that's can I make a comment? Yes, PDF can speak. Yes, I remember with the EUTML project, we've done that ages ago with underlaying text, which stopped working at some point.
PDF can speak. Most application. I mean, not every PDF reader has the support for it, but yes, Acrobat can and others can. And you can do it by the operating system thing.
Acrobat. Yeah,
but
Acrobat has a read aloud function.
Yeah, it requires, of course, if it is not tagged PDF, then certain things will not work correctly. So if you have two columns and it guesses the columns wrong, you get everything sort of from one column and the next column line by line. But if you have tagged PDF, then it reads it correctly. It gets your word order right and ordering right and everything. So yeah.
I'm mindful of the time. I was first to put my hand up. That's why I'm mindful of the time. So two very quick comments on the question. First of all, math checks, you don't have to do that by hand. There's a
I noticed that.
Node version can do that.
There's right now we are using, let me comment on this one.
Oh.
Right now we have 5 approaches that we are experimenting with, which is what Ulrike presented. Yes, of course, you would not need to do it by hand.
That was not a critique. Just the second one was, why go the MathML route? If you want to just do it as alternative media, why not? But why not leave the LaTeX in there? There's 2 reasons, obviously. If you only have the MathML again, all you
is your mic on?
All you offer is passive reading rather than being able to actively engage with the document, as you can, if you have the LaTeX in there. But my real question is, what about graphics? If I use my Tixi, can you do anything about that?
Can I say something about the math?
Yes, please.
I had a bit problems with ngPDF. I wanted to demonstrate there that the LaTeX is there too. We also embed the LaTeX source.
That is brilliant.
as file.
Well done.
And we also embed it as alternative text. If we could, currently we can't because of a clash with Foxit, but we want to. So the LaTeX source is there too. The main question is what the tools will do with it.
Yeah, and the problem that I was saying earlier is that we have to get the tools to do the same kind of thing with it. If you which as it was said earlier in the talk, the importance is not just being able to consume the stuff. The importance is also to communicate with it. So if I write a document and it will be understood by me and by him, but not by you over there, because you have a different set of tools, then the document is not good for communication. So we have to work on making sure that we get solutions that actually work throughout the box, at least.
But you also, just because something cannot be made accessible just yet, it might be tomorrow something is on the market, and then you'll have it already future ready. But the graphics question?
Come back to the graphics questions. The graphic questions depend on a number of factors. If you think about Tixi, I would say yes, that can be done by the end of the day. The question is what kind of graphics can be done. I mean, you have. If you ask us to produce what an AI tool would tell you what the graphics are actually all about, no, probably not. But what I'm thinking about is, with all the hype that is currently going on with artificial intelligence, yes, for sure. I mean, if you can feed a graphics to a sensible tool for recognizing the contents of the graphics and summarizing it in an intelligent way. Right now, I would say most of the time that doesn't work, but give it a couple of years. You get at least a good starting point, possibly. I wouldn't have thought about this 5 years ago, but I mean, give another 5 years in the other direction. I wouldn't be so surprised if you actually get graphics, alternative text being produced on a reasonable high quality. And then we can sort of basically feed that into the system automatically as well, which would reduce, maybe even free the author from producing that all the time on his source.
Thank you. So I have a question. I am Bhaskar from Bangladesh. You know, as a person with visual disability, I am facing huge difficulties when there is hundreds of thousands of PDF documents which are non-Unicoded, like many content in our language which are non-Unicode supported. That means my screen reading software are not able to read that. How you are going to deal that problem through your accessible PDF? Thank you.
Can you repeat for me the middle part of the question, maybe a little bit slower, about the Unicode stuff? The documents are not Unicode encoded because the languages are not in Unicode, or just because they are historically in fonts which are, I don't know, 8-bit?
No, the issues is like people love to use the colonial font. We have the Unicode, but there is hundreds of thousands of content which is non-Unicode supported. That's why we visually get people unable to read that PDF documents, and that's a big challenge for our Bangla content. Thank you.
I'm a little bit lost. I mean, maybe I misunderstand it. Your documents are not Unicode encoded because why?
Because people love to use the non-Unicode content, and it was
the non-Unicode what font?
Font. The font are not Unicode supported.
Okay.
That's why screen reading software
So
cannot read.
There are fonts out there that are put into the PDF which are not Unicode. Okay, that's what you're saying.
Yes.
And now the question is, how do you make this accessible? Well, actually, that's not so difficult.
Yeah.
If you have a font which has characters which are in theory in Unicode, but they are in the wrong place because the font is not Unicode encoded, then you can give it a map that translates from your font position to the Unicode information, so that the system and the PDF knows this is a Unicode, this is the following Unicode character. So this is the way 8-bit fonts are handled or can be handled in PDF tag and still show Unicode characters in the PDF.
Yeah, thank you very much.
Any other questions? Okay.
Thank you. It's extremely interesting with the accessible PDFs, but there are some kinds of contents that in principle could be accessible, like musical scores. But did you do any works with those other kinds of contents, which might be interesting for some people?
No. Well, solve the big problems first, I would say. And this is right now, we want to have text and mathematics and hopefully parts of graphics, and so accessible and properly tagged. From a structural point of view, what we are currently providing naturally, I would claim, translates to something like music scores. If you have those in a LaTeX source, why not? That would not be that difficult to do, but it's not on my forefront, to be honest, to dive into such packages and make them, or help the developers to make them Unicode accessible. But accessible. But of course, and this is the beauty, I would say, of or the chance why we might actually succeed. LaTeX is an open-ended universe. So they are out there, as I said, 5,000 packages or more, and there are coming new ones once in a while because somebody has a great idea and wants to make the recipe for Japanese ramen noodles book class, and then you end up with such a class on the archive. And it would not be accessible unless this guy or this lady is making the effort. But the point is, when we actually achieve that a large portion of the LaTeX documents with standard sort of set of packages in use are accessible and people become used to the fact that LaTeX can do this, there will be a community pressure on developers to actually make their own packages as well accessible, even those that we are not accessing. So maybe then at that point in time, the next musical package for flute recorder notation, ABC or whatever, the person is automatically thinking about, yes, maybe I should put some tags in here so that it ends up in the PDF as structure that can actually be further processed and the document becomes accessible. Long-winded answer, yeah.
Okay. 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 Thank you very much.